Hi everyone, I'm recording this video for the peer graded assignment for machine learning foundations for product managers. The data is for the combined cycle power plant, which basically is an assembly of heat engines that work in tandem from the same source, right? So uh, the assignment is to build a model, validate and evaluate, and the peer-to-peer graded gradation would be based on how the modeling approach was. So what was the model, how was it set up? Did you compare at least two different models, to come to a conclusion? And then was your model evaluation reasonable enough to determine performance of your model? And then was it interpretable, right? Did you correctly understand and clearly communicate how the performance of your model was, right? So those are the criterias to be graded. Now, the data that we have got for the combined cycle power plant is of temperature and other variables. So these are related to the gas turbines, steam turbines, heat recovery systems, and the total number of input values or data that we have got is 9,568 readings, right? If you see the columns that we have in the data, they are on temperature, ambient pressure, relative humidity, exhaust vacuum, and then we have to predict based on our model. We are targeting to predict the PE value, which is net hourly electrical energy as an output, right? So they've also given the overall range for each of these input features. Now, the approach that we have taken is multiple linear regression. So here each feature in numerical has a relatively linear relationship and does not require any hyperparameter tuning, right? That's the approach we have. Now the features that we have selected, we will have two models. So the first one we would do with all the features. Uh, that would be the start, and then we would validate the model. So for validation, we'll have to split the data. So we have just split it 16 by 84, which is 1/6 of the data approximately, the k-cross validation process. Uh, so like I mentioned in the feature selection, we have taken all initially. Then the second model, we will probably have reduce one or two features and see how that shapes up. R square would be used to validate the models. And finally, for evaluation, we'll use MAPE, which is basically going to give us the output for evaluation. Now, once we run the model, taking into account all the four features and the test samples of about 1, 5, 6, 8, 16% of our data, the R square value that we got was around 0.93 or 0.29 929, right? The MAPE was 0.008, right? So that's the accuracy and or the R square value that we have got. Now, if we again look at the different features that we have, the relative humidity was having slightly lesser correlation as compared to the other three. It's a comparative thing, and this is just to understand and create the second model. So we drop the relative humidity for the second model and just run the model with three features, right? And here we see that the R square has in fact dropped to 0.917 or 918. And the MAPE is at 0.00849, right? So the earlier model. So with that, here we have on the first model itself, we are able to get a better R square value of 0.929. and that helps us to interpret the model as well, in a way why we have taken all the four features. We are able to explain how the correlation works, as well as what are the outputs that are coming out of the model. Um, that's for that's for the model comparison as well as the output from this exercise. Thank you.